This is for Algebra 1. This is working with quadratics. The first thing it wants you to do is fill in the table below, and it wants you to leave the area in terms of pi. Remember, I told you earlier in the year that anytime you have something using the process column, you do not have to fill that out. As you're doing this, you're finding the area of a circle, which we know the formula for the area of a circle is pi r squared. So if your radius is 1, it would be pi times 1 squared, which is 1 pi. If your radius is 2, it would be pi times 2 squared. 2 squared is 4, so we have 4 pi. If it was 3, it would be 3 squared, so 9 pi. 4 would be 16 pi. 7 would be 49 pi. And 8 would be 64 pi. So what is the range and the domain for the data? Remember, domain is always talking about your x, and that's going to be the left side of your table. So it's going to be from 1 to 8. The range is always your y, or the right side of the table, and it's going to be, technically, it's from 1 pi to 64 pi. So how are they getting from pi? They wrote it 64 pi, so that works good. Okay? So then you use your domain and your range to figure out a good window. Remember, a window, like in your door, it just is what you can see through that door. The bigger the window, the more you can see. Well, it's the same thing. It's what you're going to see on your graph. Okay, so your x, min, and max need to come from your radius. You need to be a little smaller than the smallest and a little bigger than the biggest. So smaller than 1 and bigger than 8. So I would probably say like 0 to 10. As long as you're just going as high as 10, I think your x scale can be 1. It's just going to count by ones. Now your y minimum to your y max, when you look over here at your table, you think of it as being pi to 64 pi. I'm going to get a little smaller, a little bigger. So you can start at 0. But instead of 64 pi, they got 202. Now where do you think that came from? If you take your calculator and do 64 times pi, which is second and the rooftop, it tells you 201.06. That's where they're 202. It's just a little bigger than 201. And since you're going that high, you're going to have to count by something much larger. Counting by 1s or 2s or even 5s is not going to work. They recommend counting by 20s. Okay, so then it wants to know what's your independent and dependent variable. Anytime they're asking for variables, they want words or letters. Independent is going to be from your x side. So what word is above the x side of your table? Radius. And dependent is going to be from the y side. What word is at the top? Area. So then what is the parent function? Okay, if you look up here, and we did this a little bit yesterday with our dilation, and we do our first difference and our second difference. So when you subtract 4 pi minus 1 pi, it's 3 pi. 9 minus 4 is 5 pi. 16 minus 9 is 7 pi. Okay, so it's not linear, is it? 5 minus 3 is 2. 7 minus 5 is 2. Guess what? It's going to be quadratic. So what is the parent function? Well, what is your parent function for quadratics? Parent function for quadratic is y equal x squared. And they're justifying it by saying that the second difference is the same as you go down. Okay, so a new situation. Once again, when we have a process column, we get to skip it. We have a ball dropping from a height of 100 feet, and they give you a formula. Negative 16 is acceleration due to gravity, just kind of some background information. Basically, they've given you a formula. When you have a formula, you go to y equal and you put it in your calculator. So we're going to say negative 16 x squared plus 100. Okay, now they're giving us really weird numbers for our x, so we want to go second and table set, and we're going to set it down here at ask. Okay, at your independent, you want to set that to ask, so that when we go to our table, we can tell it, well, what is the answer if we put a 1 in? And it's 84. Okay, so then we go, okay, well, what if we put in a 1.2? And you get 76.96. And we go, well, what if we put in a 1.4? And it's 68.64. And you would continue. 1.6 is going to give you a 59.04. 2 is going to give you a 36. And 2.5 is going to give you a 0. Okay, so we just put our equation in y equal, told our table to let us ask, and we looked at our table to get these answers. Moving to the next page. What is the range and the domain? Okay, remember, you're going to have numbers and you're going to have them from the table. Your domain is your x values. It's going to go from 1 to 2.5. Your range are your y values. Now, it's going to be the opposite of what you would think. The lowest is 0, okay? And on our table, the highest is 84. Let's see what they do for their range. Your domain is 1 to 2.5, and your range is 0 to 84. They just got these numbers from the table, but make sure you go from smallest to biggest, not the order it shows up on the table. So using your domain and range, you want to set a window. Your x min is going to be a little smaller than 1, so I'd go 0. The x max has to be a little bit bigger than 2.5, so they went to 5. Small range of numbers here, so you're just going to count by ones. Your y min is 0. Your y max needs to be a little more than 84, so they said 90. And then they counted by 5s. I would be okay with counting by 10s here, either way. So what are the independent and dependent variables? Remember, the independent variable is the word above the left side of your table. So if you go back and you look at your left side of your table, and you look at above it, it says seconds. The right side says height. Go ahead and keep that in mind. So your independent variable is time, or seconds would be fine. Your dependent variable is the height. So what would the coordinate pair 1.85, 45.17 mean? Well, remember that the independent, so your independent is going to talk about the first, and your dependent is going to talk about the second. So basically, independent was time, so at 1.85 seconds, the height is 45.17. Okay, so if they give you a table of values and they want you to figure out, is it quadratic, is it linear, or is it neither? You're going to do our differences like we were doing yesterday. And so 12 minus 9 is 3. 17 minus 12 is 5. 24 minus 17 is 7. 33 minus 24 is 9. 44 minus 33 is 11. And 57 minus 44 is 13. So I look at these. If these numbers had all been the same, it had been 3 all the way down, it would be linear. They're not, so it's not. So now we're going to subtract and do our second difference. 5 minus 3 is 2. 7 minus 5 is 2, 9 minus 7 is 2, 11 minus 9 is 2, and 13 minus 11 is 2. These are all the same. If your second number is all the same, then it is going to be quadratic. So looking at your next one, 34 minus 30 is 4, 38 minus 34 is 4, 42 minus 38 is 4, 46 minus 42 is 4, 50 minus 46 is 4, and 54 minus 50 is 4. They're all the same. That means that this one is linear. 147 minus 124. You're just going to take your calculator, go to your home screen, 147 minus 124, and you get 23. Then you're going to do 172 minus 147. Is 25, and I continued along and filled this out for you. These numbers are not the same, so it's not linear. 25 minus 3 is 2, 27 minus 5 is 2, 29 minus 7 is 2, 31 minus 29 is 2, 33 minus 31 is 2. The second ones are all the same, therefore it is quadratic. Going to the next one, 23 minus 3 is 20, 43 minus 23 is 20, 20, 20, 20, 20. They're all the same on the first one, and so it is linear. On your assignment, do not do the first 3 and then stop. Do the entire table, because it might be down at the bottom that you see a change that causes it to be neither. So that's what you're going to have to be able to do on your assignment. If you have any questions, you need to talk to me.